The MAC address table is the most important table on our Catalyst switch. Why? Because it tells the switch what to do with frames. Without the MAC address table, our switch would be no better than a hub. That's right, a bit spitter, a device that just floods information out all ports except the port it came in on. But because of the MAC address table, which we can view by typing in show MAC address table, we have the ability to have efficient forwarding devices, because the MAC address table tells the switch what to do with the frame. Notice here that we have some static entries and we also have some dynamic entries. So static entries are entries that were hard-coded on the device by Cisco before it left the manufacturing floor. And we also have static entries that can be done by you as an administrator. So if you wanted to manually tell the device that this particular MAC address lives out this particular port, you can do so. But that's not a very efficient way in our very large-scale organizations to manage our switches. So we have the dynamic option as well, which is the default option. Our switches will dynamically learn MAC addresses on the fly. They'll also dynamically change these entries on the fly if needed. So when we analyze this MAC address table and we look at the dynamic entries, how were they inputted into the MAC address table? Well, they're inputted in the MAC address table based on the source MAC address in a frame. So we have a frame that arrives inbound on an interface. Focus on ASW1 right now in the topology. We have a frame that comes from PC1 inbound on fast Ethernet 0/1. Well, that frame needs a MAC address. It's going in the source field and also in the destination field. But we're focused on the source MAC address right now. So the source MAC address of the frame is going to be ending in 06D6. That's PC1's MAC address. So when that frame arrives inbound on fast Ethernet 0/1, the switch says, okay, I just received a frame inbound on fast Ethernet 0/1. What is the source MAC address of that frame? And then it puts that in the MAC address table as a dynamic entry and the interface it arrived inbound on. Now, why? Why does it do that? Because it knows that if it receives a frame inbound on an interface and the source MAC address is listed there, then that must mean that that device lives out that interface. It's the only explanation for that, right? If I have a frame, if a frame comes in and it says it came from a device with this MAC address, well, then that must mean the device lives out that port. So let's put that information in the table. That's our dynamic learning option here. So when we see 0800271406D6 dynamic fast Ethernet 0/1, we know that that device with that MAC address lives out that port. Likewise, when we look at CE47 here, the MAC address of PC2, we can confirm that that device lives out that port. And this is so important because now whenever ASW1 receives a frame that is destined to 06D6, it does a MAC address table lookup, and it knows it's out fast Ethernet 0/1. If it ever receives a frame that's destined to CE47, it knows it lives out fast Ethernet 0/2. So it can send the frame out fast Ethernet 0/2 and get to that device. So very, very important table we have here. The MAC address table designed specifically for our switch to make its forwarding decisions. So when you're troubleshooting and you're trying to figure out, hey, are my ports working? Is my switch learning about these devices that live out all of the ports? You're going to type in show MAC address table to verify that it's clear here. Now, can we have more than one MAC address associated with an interface? And the answer is, you bet we can. You bet we can. Just take a look at some of these examples here. Fast Ethernet 0/1 has 657A associated with it as well as 06D6. Why is that? Well, PC1 is what? PC1's what? Well, it is a PC, but right now on PC1, I'm also running a virtual machine. What does that mean? Well, it means I have my host operating system, and I also have another operating system running as a virtual machine. So really, there's two devices on PC1, meaning that there would be two different MAC addresses, one for the host, one for the virtual machine. And that's why we see two MAC addresses in this case. 06D6 being one of the devices, 657A being the other device. Every single device in our local area network needs its own unique MAC address. whether it's virtual or whether it's physical. We can see that here. But what about if we had a phone connected? If ASW1's port fast Ethernet 0/1 went down to a Cisco IP phone, does it have a MAC address? Yes. And then from there, we'd plug our PC into the phone, meaning that 2 MAC addresses would have to be learned on that port as well. What about a wireless access point? If you have a wireless access point connected into ASW1, those MAC addresses would be learned by that switch. So there'd be multiple MAC addresses associated with that interface. So let's go up to DSW1 and look at the MAC address table on DSW1. Notice how we have, let's refresh that. Let's go to our client and let's go ahead and ping. We'll ping from PC1 up to the default gateway. And we'll also do the same thing from PC2 in this scenario. And on PC2, we'll type in ping 10.1.1.1. And then when we go back to our, on DSW1, show MAC address table dynamic, we'll see CE47 lives out gig 101 and 06D6 lives out gig 101. And that makes perfect sense because when you analyze the topology, you'll see out gig 101, that's where those devices live. They live out gig 101. So whenever you're trying to troubleshoot and figure out, is my switch learning? Are the devices where they're supposed to be? The MAC address table can definitely tell you that within a local area network.